Good morning, students. Yes, 12th English medium, chapter number 3, current electricity. Okay, almost all theories, all questions over. Yes, one last question from exercise 3.15. See what is question this time. 6 lead acid secondary cells. Yes, you know lead acid. Okay, each having EMF 2 volt and internal resistance 0.015 ohm. They are connected in series connection. Okay, with external resistance 8.5 ohm. Your first question is what is current flowing from circuit? Second question is what is terminal voltage? What is terminal voltage? Yes, you are given 6 lead acid secondary cells connected in series. Connected in series. Okay, each having EMF 2 volt, internal resistance 0.015 ohm, external resistance is 8.5, find current and terminal voltage. See, these all 6 cells, they are connected in series connection and in helping condition. You know what is helping condition? Yes, you know helping condition. Each and every cell, they are connected like this, plus minus, plus minus, plus minus. Yes or no? Yes, they all having some internal resistance. It's EMF E, internal resistance R, EMF E, internal resistance R. Yes, ER, ER, ER. Okay, along with one external resistance, R. Okay, so yes, as these 6 cells are connected in series, in helping condition. In helping condition, we know what is equivalent EMF. Equivalent EMF E equivalent is equal to, if you remember equation, E1 plus E2 plus E3 plus E4 dash dash dash. Here you have 6 cells and each having same EMF. So yes, you can directly write it is 60. Clear about this? Yes or no? Yes, you can directly write E equivalent is equal to 60. What about equivalent internal resistance? R equivalent is equal to, yes, R equivalent is equal to, it is 6R. Because each cell having same internal resistance. Clear? So first of all, for this series connection, find equivalent EMF, find equivalent internal resistance. Clear about this? Now you can redraw this figure like this. One cell, one external resistance, its EMF is equivalent, its internal resistance is R equivalent, its resistance, external resistance R. Let the current flowing from positive terminal of cell is I. That is your first question. Yes or no? How to find current? Yes, we know its equation. Current I is equal to, for one cell, we write equation like this, E upon R plus R. Yes, you know this equation. Okay, from theory of terminal voltage. I is equal to E upon R plus R. But whenever you are given such combination, write equation as I is equal to E equivalent upon R plus R equivalent. Clear about this? Now you have each and every value. E equivalent 6E. What is value of E? Each EMF 2 volt. Okay, so yes, value of E is equal to, it is 2 volt. What is value of internal resistance R? It is 0.015 ohm. Put value of E equivalent, that is 6E. Capital R, external resistance. Yes, it is given. External resistance. Okay, 8.5. R equivalent 6R. Put each and every value, you will get your answer. Clear about this? So yes, it is one simple question. It is one simple question about series helping condition of cells. Okay. What is second question? What is second question? Second question, you have to find what is terminal voltage V. What is terminal voltage V? Yes, you can find terminal voltage like this. You know its equation. What is terminal voltage? Terminal voltage. Terminal voltage. V is equal to, you know its equation, E minus IR. V is equal to E minus IR. Yes, V is equal to E minus IR because these all cells are connected with this resistance This all cells are discharging, and during discharging process, you can write V is equal to E minus IR. Yes, you have to write V equivalent minus R. Clear? Or. You can also find terminal voltage with the help of equation. V is equal to IR, where R is external resistance. Clear? So yes, it is how to find current, it is how to find terminal voltage. You can calculate this. Clear? Okay. What is question B? What is question B? Yes, after a long use, EMF of cell drops to 1.9 volt and its internal resistance becomes 380 ohm. Internal resistance becomes 380 ohm. Okay, so obviously resistance increases means current flowing from it decreases. Yes or no? Yes. Your question is, after a long use, when its EMF drops to 1.9 volt, internal resistance becomes 380 ohm, then what is maximum current from that cell? What is maximum current drawn from that cell? Okay, could the cell drive storage motor of a car? It is your question. So first of all, we will find I maximum. What is equation of I maximum? If you remember theory, I maximum is equal to, it is E upon R, EMF upon internal resistance. Yes, EMF is 1.9 divided by 380. Yes, you will get very small amount of current. And yes, that small amount of current is not enough to start motor of a car. Yes, usually we have problems. Okay, our vehicle do not start with the help of this battery. And we say that yes, your battery is discharged. Okay, then we have to charge our battery. So yes, it is that problem. Okay, after some time, internal resistance of battery increases, its EMF drops, and yes, current drawn from cell is not enough to start motor of the car. That's why we have to charge battery regularly. Clear about this? So yes, it is one sum related to series connection of cell. Clear? Okay. With this, yes, your chapter 3 is over. All theories, all exercise question, all illustration. Now we will see some extra questions. Okay. Yes, we have one extra question. See, if length of a conductor is increased by 50% after stretching, see, stretching and cutting is different. In stretching or compressing process, volume remains same, but in cutting process, volume is changed. So remember the word, okay? If length of a conductor is increased by 50% after stretching, what is change in resistance? Change means increases or decreases. We have to see. Okay, so see, first of all, length of conductor is increased by 50%. Then what is change in resistance? So first of all, you have to make one relation between two quantities given. Length of conductor and resistance. What is relation between them? Yes, you know relation between them. You will say, sir, it is simple. R is equal to, it is rho L upon A. Then simple, R is directly proportional to L. R is directly proportional to L. Wrong. Why wrong? Here, if length of conductor is increased by 50% after stretching, yes students, if you stretch wire, its length increases. Rho, resistivity, it remains constant because same material. Yes, length increases, but what about area? Cross-sectional area decreases. Cross-sectional area decreases. So we cannot write R is directly proportional to L, because as length changes, cross-sectional area also changes. Clear about this? Okay, so yes, then what to do? Just stretching, I told you, okay, in stretching process, volume remains same. See, I can write this equation as rho L square upon AL. Yes or no? Rho L square upon AL. Rho L square upon AL. Multiply L in numerator and in denominator. Yes, is equal to, it is rho L square upon AL. A cross-sectional area, L length, you know that cross-sectional area into length, it is called volume. Rho resistivity, material is same, then resistivity will be same. Volume after stretching or compression process, volume remains same. So yes, here I can write R is proportional to L square. R is proportional to L square. So yes, this point you have to remember. It is one important point. Okay. In stretching process, resistance does not depend only on length. It also depends on cross-sectional area. So it is relation. R is proportional to L square. Clear about this? Okay. Now, what is knuckle? See, if length of conductor is increased by 50%, I am assuming initial length L1 is equal to L. Then what is L2? L2 is equal to, it is L plus 50% of L. Okay, you have to understand language, English. Okay, if length of conductor is increased by 50%, initial length is L plus 50% of L. Clear? So yes, is equal to, it is L plus, how to convert this percentage? You know, it is 50 divided by 100 into L. Then it is L plus, it is 0.5 L, means it is 1.5 L. Clear about this? It is 1.5 L. Clear about this? Okay. So yes, it is relation between initial length and final. Now what is relation of resistance? R is proportional to L square. R is proportional to L square. So yes, you can write this as R2 upon R1 is equal to, what is final length? L2, 1.5 L. What is initial length? L. It's whole square. L cut L. Clear about this? Clear about this? Okay. Okay. So R2 is equal to, it is 1.5 whole square. Here it is R1. Here it is R1. To see first result, R2 is equal to 1.5 whole square R1. 1.5. Yes, what is 1.5 into 1.5? It is 2.25. It is 2.25. Yes or no? Yes, yes. Okay. So yes, R2 is equal to 1.5 into 1.5 means, yes, you can write directly this one. Okay. R2 is 2.25. R2 means if length increases, resistance increases. If length increases, resistance increases. Yes or no? Yes, it is. Yes, it is. Clear about this? Clear about this? Okay. Now, what is change in resistance? You have to find any change in percentage. Remember 11th chapter 2, percentage error. What is percentage error? For example, if I say percentage error in length, then how to write delta L upon L into 100? Yes or no? Yes. So here, how to write percentage error? Percentage error or percentage change is equal to change upon original value into 100. Change upon original value into 100. How to write change? Always write change R2 minus R1 upon, here it is R1 into 100. Clear about this? What is R2? Yes, it is 2.25 R1 minus R1 divided by R1 into 100. Clear about this? 2.25 R1 minus R1. 1.25 R1. Yes, it is right. Divided by R1 cut. Okay, so here it is 1.25 into 100. So your answer is 125 percentage. 125 percentage. And yes, it is positive. It means resistance increases by this percentage. Resistance increases by this percentage. Clear about this? So what is your question? If length of conductor is increased by 50% after stretching, what is change in resistance? What is change? Increases or decreases? Yes, increases. By how percentage? 125%. Clear about this? Yes, it is long method. There is also one short formula, but you have to remember this method, okay, for any kind of changes. Clear about this? You can also find if length of conductor is increased by 100%, after stretching, then what is change in resistance? By 100%, then what is change in resistance? Write your answer in comment box. Okay, now we will see one extra question. See, calculate current flowing through resistors. You are given 3 resistors, 10 ohm, 20 ohm, 30 ohm, and yes, you are given 4 points, 1, 2, 3. Okay, having potentials 10 volt, 6 volt, and 5 volt. Second question is calculate potential at junction. Okay, see, whenever you are given such circuit, first step is to assume current distribution. To assume current distribution. Okay, now here how to find current distribution? You are given 10 volt, 6 volt, 5 volt, you are not given cell. Okay, see, current flows from higher potential to lower potential. This point having 10 volt potential, 6 volt, and it is 5 volt. So yes, you have to assume, okay, you have to assume that current flowing from this first point is I. Clear about this? Okay, yes, current flowing from this is I. At this point, yes, it is called junction. So from this point, current gets divided into branches. If I am assuming current flowing in this branch is I1, then according to Kirchhoff's first rule, what is current flowing from this branch? It is I minus I1. It is I minus I1. Clear about this? So yes, first of all you have to write only one statement. Okay, a current distribution is as shown in figure. Current distribution is as shown in figure. Okay, now you have to find first of all current flowing from each and every branch. Means you have to find two currents, I and I1. Yes, again we have solved such questions. You have to find I and I1, two variables. Means we need two equations. So yes, we have to take two paths. Yes. See how to take. Let indicate this point as 0 or O, whatever. Okay. Now, how to take path? See, first of all, take path 1, 0, 2. Take path 1, 0, 2. How to write equation? See, at this point, what is potential? It is 10 volt. Starting from this point. So, yes, it is 10. Okay. Then, in our path, first we encounter resistor 10 ohm. Current flowing from it is I. We are going from 1 to 0 to 2. Means we are moving in direction of current from this resistor. Yes or no? Yes. You know, when we are moving in direction of current, potential drops. So yes, you have to write minus 10I. Minus 10I. Clear about this? Okay. Then yes, this resistor 20 ohm. Current from it I1. We are moving in direction of current. So yes, here it is minus 20 I1. And now we reach to point 2. Means here, what is potential? Potential is 6. So here, how to apply Kirchhoff's law? Simple. First of all, starting from this point, 10 volt, 10 ohm into I, minus 10I. Why minus? Because we are moving in direction. 20 ohm, current I1, again we are moving in same direction, minus 20 I1. Finally, we have reached at this point, so is equal to 86. Clear about this? Okay. How to simplify this? Yes, it is 10 minus 6, it will be 4. Is equal to, it is 10I plus 20I1. Equation number 1. So it is equation number 1. Clear about this? Okay. Now you have to take another loop. Now we will take this loop. Yes, you know 1, 0, 3. Okay. So take path 1, 0, 3. Take path 1, 0, 3. Starting from this point, yes, it is common. 1, 2, 0, it is common. So take point 10. First resistance 10 ohm. Current flowing from it is I. We are moving in direction. So yes, it is minus 10I. It is minus 10I. Then in this direction, resistance 30 ohm. Current I minus I1. We are moving in direction. So yes, it's negative sign. Minus 30 I minus I1. Then yes, at this point 3 having potential 5. So here you have to write is equal to 5. Clear about this? So it is how to apply Kirchhoff's law on a straight path. Okay, now yes, how to simplify this? See, 10 minus 10i minus 30i minus plus 30i1 is equal to here it is 5. Clear? So 10 minus 10i minus 30i means it is minus 40i. Okay, plus 30i1 is equal to here it is 5. Here it is 5. Okay, now it is 5 is equal to 40i minus 30i1. Equation number, yes, you have two equation. 4 is equal to 10i plus 20i1. Second equation, 5 is equal to 40i minus 30i1. You have two variables, I and I1. You have two equations. You can easily find. Clear? Now how to find? It is your subject. Okay, how to find? Okay, solve these two equations. You will get value of I and I1. Clear about this? Okay. Second question. Yes, I and I1 you have to find. Second question is calculate potential at junction. Where is junction? Yes, it is the only junction. Point O is junction. You have to find potential at this point. Okay, V0 is equal to what? Simple. Take this part. See, take path 1. This first resistor 10 ohm, and then here it is point O. Okay, how to apply Kirchhoff's law? First, from this point, it is 10 minus 10 I, and then we have reached to this point. So yes, it is V0. Simple. Okay, 10 I you will get from this equation. Put value in this equation, you will get value of. Clear? So it is how to apply Kirchhoff's law. Clear about this? You have to find what is value of I and what is value of I. Okay, now next question. Yes, you are given one circuit, okay, having 5 resistors connected with a cell of EMF 10 volt. Your question is find current flowing from BC, means between B and C. What is current flowing? See students, whenever you are given 5 resistors, first you have to assume, yes, it may be a Western bridge. Okay, Western bridge, 5 resistors, 5 conductors. How they are arranged? See, we will reconstruct this figure. Cell is connected, battery is connected between points A and B. So first of all, take 2 points, A and B. Cell battery is connected between these 2 points. Okay, between these 2 points, A and B. Now remaining points are B and C. And see, they are not common points, okay? A, B, B, C, C, D, they are not common points. So yes, I am writing B and D like this. It is B and that it is C. Now simple, observe this figure and reconstruct here. This resistor 100, this resistor 100. It is between A and B. 100. Simple? Okay. This resistance 100 ohm. See, it is between this point and C. Now this point is common to point A. You know what is concept of common point? Yes, you know. Okay, this point is common to point A. So this 100 ohm resistor is connected between A and C. Where is A? Here it is. Where is C? Here it is. So yes, this resistance is 100. Clear about this? Yes. Then this resistance, it is between B and C. Yes, it is so simple. Between B and C, it is 100 ohm. It is 100 ohm. Clear about this? Next one is, yes, this 200 ohm, it is between C and D. It is between C and D. Here it is C and here it is D. So yes, it is 200 ohm. It is 200 ohm. Last one, this one 200 ohm between B and D. So yes, it is between B and D. It is 200 ohm. You have to find what is current flowing from this branch BC. How to find? See. Observe, this circuit is nothing but Western bridge. It is It is Western Bridge. And yes, observe this thing. See, R1 upon R2 is equal to R3 upon R4. Yes, it is. 100 upon 100 is equal to 1. This side 200 upon 200 is equal to 1. R1 upon R2 is equal to R3 upon R4. Western Bridge is in balanced condition. Is in balanced condition, and we know that in a balanced condition, what is current flowing from this part BC? It is 0. IBC is equal to 0. Remember theory of Western Bridge. Okay, when R1 upon R2 is equal to R3 upon R4, current flowing from galvanometer IG, we have considered 0. Clear about this? So yes, first of all, you have to reconstruct figure. It is Western Bridge. Then you have to check, is it in balanced condition? Yes, 100 upon 100 is equal to 200 upon 200. It is in balanced condition. So you can easily find what is current flowing from this. Current flowing from this part, that is from IBC, is equal to 0. Clear about this? So yes, it is one question based on Western Bridge.